Hello, Mrs. Below here. In this video, I'm going to be going over how to do the first example for the VSEPR or VSEPR Virtual Lab. Again, that stands for Valence Shell Electron Pair Repulsion. So in this lab, we're going to be exploring the three-dimensional structure and shapes of various covalent molecules. So the first thing we're going to do is we're going to click on this link to open the PhET, and we're going to select Model, and it will default to this. Next, we're going to select Molecular Geometry. So then this will tell us what the molecular geometry is: linear, bent, tetrahedral, so on and so forth. But before I get to this, I want to go over this part in the lab. So once we have our PhET set up and ready to go, we're actually going to start by drawing the Lewis dot structure for this particular molecule. Then we're going to build it in the PhET, so then we can figure out what its molecular geometry is. So for my first one, I have CO2, which is carbon dioxide. So this guy right here, so we have carbon and two oxygens. So I'm going to be putting the carbon at the center. If you ever have carbon or an element that you just have one of, you're going to put it at the center. And then we're going to put those two oxygens around it. Next, I'm going to draw my valence electrons around each element. So carbon is in group 14. It has 4 valence electrons. Oxygen is in group 16. It has 6 valence electrons. Okay, I'm actually going to make these 2 different colors, just so that it's a little bit easier to see the differences when we're moving stuff around. Okay, so now I have to rearrange these so that each element is surrounded by 8 valence electrons. So first thing I'm going to do is I'm actually going to move this guy over, because I can see, oh, okay, these electrons, we can share them, okay? And also, I'm going to actually back up for 1 second. We're going to move him. We're going to put him right there. Okay, so again, we need to surround each element with 8 valence electrons, okay? So right now, this oxygen has 6 around it, and the carbon has 4 around it. Okay, so if the oxygen is going to be sharing this electron, that would be 7 valence electrons that would surround it. So it only needs 1 more. So I'm actually going to take this electron and I'm going to move it here. And then this electron that's by itself here for the oxygen, I'm going to move it here. So now I can see that this oxygen is now surrounded by 2, 4, 6, 8 valence electrons. And these guys right here, these electrons are being shared, and that's going to create our bond. I'm going to do the same thing with the other oxygen because our carbon is only surrounded by 2, 4, 6 valence electrons right now. So I'm going to go ahead for this oxygen, I'm going to adjust it a little bit. Instead of drawing it like this, I'm going to draw it like that. And I'm going to go ahead and move this guy over. So now these electrons are being shared. Again, we don't have the carbon surrounded by 8 valence electrons. It only has 2, 4, 6, 7 right now. Same thing with this oxygen. So I'm going to take this electron and I'm going to move it over here. And this electron, I'm going to move it over here. So now they are sharing. So now I can see that the carbon is surrounded by 8 valence electrons, and each oxygen is surrounded by 8 valence electrons, and these are the electrons they are sharing. So for my final Lewis dot structure, we have the carbon and the 2 oxygens. We're just going to move this guy up real quick. Oopsie. We have the carbon in the center. We have the 2 oxygens. These oxygens each have 2 lone pairs, which makes sense. And then these electrons are each being shared, so each of those is a bond. So we have a double bond there, which makes sense. Carbon can form 4 bonds. Oxygen forms 2 bonds and is surrounded by 2 lone pairs. So now we have our Lewis dot structure drawn for our carbon dioxide or CO2. So now I'm going to create this in the PhET. So I'm going to go ahead and do a split screen. So 2 things that we have to look at when designing this is the central atom, which is that's in purple right here. So in our situation, this carbon atom is this purple atom right here. Now I'm going to go ahead and just get rid of those 2 for now, just so I can start with the carbon. The first thing that we want to ask ourselves is how many elements are bonded to the central atom. So again, this is the central atom right here. So this carbon has 2 atoms bonded to it, which is those oxygens, and those bonds happen to be double bonds. So what I'm going to do in the PhET is this one right here that has 2 bonds, I'm going to add 1 and 2 of those, and I'm just going to move it. So now it looks like this guy right here. The last thing I have to ask myself is, does the central atom have any lone pairs? And it does not. So again, these are lone pairs. If you do have to add lone pairs, you just have to click this to add them. But since this doesn't have any lone pairs, we do not need that. So this is my final structure, and I'm going to take a screenshot of this and paste it in the space to the right. And we're just going to paste it right there. So now I could see that 3-dimensional structure. And then I'm going to fill in these questions here, which we kind of already answered. So we said on the central atoms on the central atom, so that was 2 that were bonded. The 2 oxygens were bonded to the carbon, which was the central atom. And then there were 0 lone pairs on the central atom. And according to this lab according to the PhET right here, the molecular geometry, which is what we're interested in, it says linear. And that is how we do the first example for this lab.